Hi everyone, so continuing our series on rectangular waveguide, now we are going to find the waveguide parameters. So some parameters we are going to find. Which parameters we need to find, that we will see. So for both TE and TM mode, this was your h square. What was the definition of h square? What was the name of h square? Transverse propagation constant. H was transverse propagation constant, and that was equals to kx square plus ky square, and that was equals to gamma g square plus omega square mu epsilon. So this was there for both TE and TM, right? Now, what was the value of kx? Kx was m pi by a whole square and ky was n pi by b whole square, and that would be equals to gamma g square plus omega mu epsilon. So forget about this h square now. Now what we are getting here, our gamma g is equals to, what will be your gamma g? Omega square mu epsilon comes here, then what do you get? Just a second. Yeah. So this omega square mu epsilon comes here, then what we are getting? So gamma g is equals to m pi by a whole square plus n pi by b whole square minus omega square mu epsilon. So this is what we are getting. Now this gamma g, this is your gamma g. Now this value, this internal value, this expression you don't need to remember, okay? If I put any star mark, then only you need to remember that expression. So this expression you don't need to remember. Now we will make some conclusion out of it. Now this particular expression, I am not talking about complete gamma g, I am only talking about whatever that is there under the root. So under the root you are having this expression. So now this expression can be either positive, or it can be 0, or it can be negative. Now let me know one thing, what is gamma g is equals to? Gamma is equals to alpha plus beta g. Why am I writing beta g? Beta g means propagation, guided phase constant. That means beta is our phase constant of uniform plane wave. That if our wave was propagating in open space, then that would be our beta. And what do I mean by beta g? Beta g means if our wave is propagating inside the waveguide. If our wave is propagating inside the waveguide, then what will be their phase constant? So that I am calling as beta g. And why I did not write alpha g here, that you will understand. Okay, you will understand why I did not write alpha g. Okay, so this is our gamma g. Now if this value is positive, then what gamma g will be equals to? Gamma g will be equals to alpha. Say yes or no. And if this value is 0, then gamma g will be equals to 0 only. And if this value is negative, then what will happen? The negative sign can come outward. Let's just say this value is minus 5. Assuming that this value is minus 5. So under root minus 5 will be there. Then under root minus 1 can come outward, and under root 5. So what it will become? Under root 5j. So what gamma g will become? J beta g it will become. Right? Depending on this value, either it is positive, negative or 0. Based on that you will have alpha, 0 and beta g. So the thing is, inside the waveguide, alpha and beta g cannot be present simultaneously. Either beta g will be present or alpha would be present, because you can see the expression of gamma g here. Previously, what was the expression of gamma we were getting? Like this, j omega mu upon sigma plus j omega epsilon. So here gamma could be complex. Gamma value could be complex here. So alpha and beta was there simultaneously. But now the scene is either it will be positive, 0 or negative. So either you will have alpha or 0 or j beta g. Now if the wave is propagating, that means certainly it need to have some phase constant. If wave propagates, what do you mean by phase constant? What do you mean by phase constant? Then that in one wavelength, how much phase is changed? 2 pi by lambda, that is your phase constant. So if wave is propagating, then certainly there has to be beta g. If you remember E naught e to the power minus j beta z we used to write. So if propagation is there, that means beta g has to be there. And if beta g is not there, that means there is no propagation at all. So what is the condition of no propagation? What is the condition of no propagation? That either this number becomes 0 or it becomes positive. So that means my m pi by a whole square plus n pi by b whole square is greater than omega square mu epsilon, then it is known as non-propagating mode. and it is also known as evanescent mode. Evanescent mode. It is also known as evanescent mode. The name of this is non-propagating mode. And when we were studying these things, non-existing mode, these mode doesn't even exist. But here, even if there is some existing mode, let's just say TE20 is there, TE20 is there. So this is existing mode. Now I will put 2 value here, 0 value here, and I will find the value of omega mu epsilon. All these value I will put, and if this condition is satisfied, then even TE20 will also not propagate. Although this is a possible mode, but still it will not propagate if it is following this condition. Are you getting this point or not? So our guided wavelength, our guided phase constant, not phase constant, our guided propagation constant is coming out to be this value. It could be positive, negative or 0. So if this guy is greater, that means this value would be positive, or equal sign I can also put. Right, because if they are equal, then it would be 0 only. So that means if beta g is not there, if this is the condition, that means your beta g is equals to 0. If beta g is not there, that means it would be non-propagating mode. And what about propagating mode? So for propagating mode, m pi by a plus n pi by b whole square should be less than omega square mu epsilon. Do you agree to this point? Right? Now what I can do is that this omega square mu epsilon can be written as 4 pi square f square mu epsilon, right? And here what you are having, m square by a square plus n square by b square into pi square, right? Now pi square and pi square can get cancelled. So what you are getting, f square is greater than 1 by 4 mu epsilon, 1 by 4 mu epsilon, and then here you are having m by a whole square plus n by b whole square. So can I give under root to both of them? So what I can write now, that my f will be greater than 1 by 2 under root mu epsilon. What did I do? 4 mu epsilon. So what did I do? I took the under root. So under root of 4 is 2. So 1 by 2 under root mu epsilon is greater than, should be greater than m by a whole square plus n by b whole square. So this expression you are getting, that your frequency should be greater than this. So what did you get to know? That let's just say this is my range of frequency. So this is a particular frequency. I am calling that frequency as FC. I am calling that frequency as cutoff frequency. Cutoff frequency. That if your frequency is greater than this value, then here propagation will be there. And if your frequency is less than this value, then there would be no propagation. So your waveguide behaves as a high pass filter. What we got to know from here, waveguide behaves as high pass filter. If you have studied analog, then you would know what do I mean by high pass filter. So high pass filter means it will pass only after a certain frequency. After a certain frequency, it can pass all the frequency band. So it can pass FC or greater than FC, because you see here that f has to be greater than a certain value, and this value is known as FC. That your f has to be greater than FC. Okay. So now what do you think? What is the value of FC you are getting? So your FC is equals to, your f has to be greater than FC for propagation. For propagation. So what is your FC here? So this value is equivalent to FC. So 1 by under root mu epsilon, what is that? Phase velocity. Phase velocity of uniform plane wave. Are you getting this point? If our plane wave was propagating in open space, then what will be the phase velocity? That is your Vp. So Vp by 2. What is the formula of Vp? 1 by under root mu epsilon, right? Vp is omega by beta. And what is beta? Omega upon beta is omega under root mu epsilon. Now someone would be thinking that, sir, why you are not applying this formula, the bigger one, omega mu epsilon by 2, then another under root. Why you are not applying this formula? Because what we assumed a perfect dielectric, that means sigma equals to 0 we have assumed. So that's why I am not applying this formula. Okay. So if sigma is equals to 0, then which formula you get? Omega under root mu epsilon only. So that's why I am applying this formula. Okay. So if you are having that if you are having that doubt, then that doubt is also clear. So FC is equals to Vp by 2 under root m by a whole square plus n by b whole square. So this is the first star I am putting. So this formula you need to remember. Cutoff frequency of a rectangular waveguide, Vp by 2 under root m by a whole square plus n by b whole square. Anyway, you need to remember it. Okay, I will take a pause because I am finding some difficulty. Then I will come back. Yeah, so what we have seen the formula of cutoff frequency. Now at cutoff frequency, you can write down at f equals to fc, or you can write down at omega equals to omega c. Your gamma g, your guided wavelength will be equals to 0. Sorry, your guided propagation constant will be equals to 0. Why is that so? Because for greater than fc there is propagation, for less than fc there is no propagation. That means here your gamma g is positive and here your gamma g is negative. If gamma g is negative, that means there is propagation. If gamma is negative, that means there is propagation. If gamma is positive, that means there is no propagation. And at fc your gamma g would be equals to 0. So at omega equals to omega c, your gamma g would be equals to 0. So if I put omega equals to omega c in this expression, this gamma g would be equals to 0. So from here what I am getting? Omega c square mu epsilon. Omega c square mu epsilon is equals to m pi by a whole square plus n pi by b whole square. Again, you don't need to remember this. Somewhere we will be using it. That's why I have wrote it down. Are you getting this point? So till now you only need the formula of cutoff frequency, and you understood that your waveguide will work as a high pass filter. For a frequency lesser than fc, there will be no propagation. For a frequency greater than fc, there will be propagation. And value of fc is Vp by 2 under root m by a whole square plus n by b whole square. What is Vp here? Vp is the phase velocity but of a uniform plane wave, not a guided velocity. What would be guided phase velocity? Guided phase velocity will be the velocity of your wave inside the waveguide. But what is Vp? Vp is this. And what is Vpg? That would be this. Inside the waveguide, that means Vpg, otherwise simple Vp. So that is your Vp. Okay. And how to apply these formulas, all these things we will learn. So you do not need to worry about all these things. Okay. So first we will develop some formula, then we will write down the summary as well, which formula will be useful, and then we will solve a lot of problems. More than 20 problems we will solve. So then it will be all clear to you. Now this expression we have got, which will be used somewhere. Okay. So if f is greater than fc, that means there is propagation. And if f is less than fc, there is no propagation. And if f is equals to fc, then also there is no propagation, but there will be oscillations. Now why there will be oscillations, that I will tell you later in this lecture only. This I need to tell you why there will be oscillations at f equals to fc. So that I will tell you, but in this lecture only later on. So cutoff frequency we have built fc equals to Vp by 2 under root m by a whole square plus n by b whole square. So this is the first formula that we need to learn. What is here Vp? Vp is the phase velocity of uniform plane wave. You certainly know what is m, what is n, what is a, what is b. You know all these things. Okay. Lambda c. What is your lambda? Do you remember lambda is equals to Vp by f? So what will be lambda c? Lambda c will be equals to Vp by fc, right? So if I put the formula of fc here, what I am going to get? What is my fc? Vp by 2 under root m by a whole square plus n by b whole square. So what you are getting? Lambda c is equals to, this 2 goes upward, so 2 by under root m by a whole square plus n by b whole square. So this is your lambda c. I am not putting star mark here. I am not putting star mark. Why is that so? Because if you remember the formula of FC, then it should be a cakewalk for you to derive the formula of lambda c. So no need to remember. Only remember the formula of FC, then lambda c will come to you on its own. Okay. Now, what you can tell from here, that if lambda is, where should I write it? I don't have space. Yeah. So if lambda is greater than lambda c, what do you think, there will be propagation or no propagation? If lambda is greater than lambda c, no propagation. If f is greater than fc, then there is propagation. But what is the relation between lambda and f? Both are inverse proportion, no? If lambda is greater than lambda c, that means this is the condition of no propagation. If f is greater than fc, that means there is propagation. So what is f? F is Vp by lambda. And what is fc? Vp by lambda c. So if this get cancelled, so what is the condition you are getting? Lambda c should be greater than lambda. So if lambda c is greater than lambda, if lambda c is greater than lambda, or you can say lambda is less than lambda c, then there will be propagation. So if lambda is greater than lambda c, then there will be no propagation. Both have inverse relation. And if lambda is equals to lambda c, that means there is oscillations. And if lambda is less than lambda c, that means there is propagation. So this conclusion also you can see. Very easy thing, very simple thing as well. So lambda c formula you don't need to mug up, you only need to remember fc formula, right? Okay. Now attenuation constant. So again this formula also you do not need to remember. What was your gamma g? Gamma g was actually kx square plus ky square minus omega square mu epsilon under root, right? Will you be able to remember this? Because you remember this thing, gamma g square omega square mu epsilon is equals to kx square plus ky square. So from here directly you can write down gamma g value. Now if gamma g is positive, if gamma g is greater than 0, that means your gamma g is equals to alpha. And if alpha is there, that means that is evanescent mode, that means there is no propagation. Okay, only attenuation is there. So what is the value of alpha? So basically the alpha is under root m pi by a whole square plus n pi by b whole square minus omega square mu epsilon, but with the condition that this inside value should be greater than 0. Is that okay for you? Right. Here also you can put again m pi by a whole square, this value m pi by a whole square omega c square mu epsilon, that you can put again. Here you can put these values again and you can get the expressions, but forget about it. This is the value of alpha. You remember this is the value of alpha. Now we need to find a guided phase constant. Beta g I need to find. And if beta g is there, that means gamma g has to be imaginary. If beta g is there, that means gamma g has to be imaginary. So what I can do, if I need to replace gamma g as j beta g, so what I need to do, I need to take minus common. So if I take minus common, what I will be getting? If I take minus common, then what I am getting? M pi by a whole square plus, minus common I am taking, no? So omega square mu epsilon minus m pi by a whole square. This I am, look, this is all about brackets. Bigger bracket omega square mu epsilon minus smaller bracket m pi by a whole square plus n pi by b whole square, right? And this minus can come outward as j. So from here, what is the value of beta g you are getting? So beta g you are getting as under root omega square mu epsilon minus m pi by a whole square plus, here this bracket should be closed, n pi by b whole square. This is the value of beta g you are getting. No need to remember all these things. Final expression that we are going to get, that you need to remember. Are you able to understand what did I do here? This beta g, how did I write it down? I hope you are able to understand it. So again, I will have to write it down on the next page. So till now we have seen. Basically, I took a minus common from here because I needed to make it equals to j beta g. So if I took minus common, j and j got cancelled. So beta g is coming out to be this. Now what is this equals to? M pi by a whole square plus n pi by b whole square. What is this equals to? That is equals to omega square, omega c square mu epsilon. So if I can call it equation 1. So from equation 1, beta g is equals to omega square mu epsilon minus omega c square mu epsilon. Right? So what I can take common? I am taking common as omega square mu epsilon. Basically, I am taking this as common. Omega square mu epsilon. So what is left here? 1 minus omega c square divided by omega square. So what I will get? Omega under root mu epsilon, then under root 1 minus omega c by omega whole square. This is your beta g. So beta g is equals to omega under root mu epsilon under root 1 minus omega c by omega square. Omega c by omega, what that would be? 2 pi fc divided by 2 pi f. So omega c by omega can be replaced with fc by f, right? What is this equals to? Beta, right? Here I should have written it more clear. What I am writing? Omega c divided by omega, that is 2 pi fc divided by 2 pi f. So omega c by omega can be written as fc by f, right? And what is beta? Beta is omega under root mu epsilon. What is this? This is your phase constant, but outside the waveguide. That means phase constant of uniform plane wave. So this is your phase constant of uniform plane wave. So what is your beta g? Beta g is coming out to be beta into under root 1 minus fc by f whole square. There you go. Another formula which should be in your mind. Guided phase constant. You do not need to remember the formula of alpha. No one will ask you. But guided phase constant beta g, that is equals to beta under root 1 minus fc by f whole square. So till now this formula and fc formula, only two formula I am asking you to remember, right? So beta g formula we have seen. Let's see the guided wavelength now. What is guided wavelength? 2 pi by beta. What is lambda? Lambda is 2 pi by beta, but we are finding guided, that means inside the waveguide we are finding. So lambda g, beta g, right? So lambda g would be equals to 2 pi by beta. What is beta g? Beta g is equals to beta into 1 minus fc by f whole square. And what is the value of 2 pi by beta? What is the value of 2 pi by beta? 2 pi by beta is the lambda. So what is the lambda? Lambda is wavelength of uniform plane wave. Wavelength of uniform plane wave. So lambda g is equals to lambda divided by 1 minus fc by f whole square. This is your lambda g. Do I have a page? Okay, yeah, I have space. So this is your lambda g. You should keep it in mind. Okay, if you can remember beta g, then very easily you can remember lambda g as well. The thing is, in lambda g, this is going downward, this expression, and here this is coming with beta g. How do I actually remember? When I studied it for the first time, how do I remember it? So beta g Beta sounds as beta, and if you know Hindi, then beta is known as son or daughter. So if you are someone's beta, then you have to stand by him. You have to stand by him. That means you need to stand by your father. If you are someone's beta, then you need to stand by your father. Here, this expression is going down. He is not standing by, but this expression is coming with beta. So this is the way I remembered it. Okay, these kind of tricks comes to me when I feel like stuck in the examination. Then certainly these kind of things click to me. Beta G. Okay, beta G. Beta has to stand by his father. So here 1 minus FC by F will come. It will not come downward. The confusion will be that beta, whether here under root will come or here under root will come. So it has to stand by him. So that's why beta under root 1 minus FC by F whole square. Without any trick or anyhow, you need to remember these formulas. You cannot derive in the examination. So anyway, you need to remember the formula. If you remember the formula for beta G, then certainly you can remember the formula for lambda G as well. Right? Yeah. So now let's see more things. What is your FC by F? What I can replace FC by F as? What is FC? Can I replace FC as VP by lambda C? Because what is lambda? Lambda is equals to VP by F. Right? So from here, F is equals to VP by lambda. So can I replace FC as VP by lambda C? And your F as, what is your F? F is VP by lambda. Right? So FC by F, this is your FC by F, can be replaced with lambda by lambda C, because both have inverse proportion, both have inverse relation. No, lambda is inversely proportional to F. So FC by F can be replaced with lambda by lambda C. So what I am getting here now, that my lambda G is equals to lambda divided by under root 1 minus lambda divided by lambda C whole square. So this result you can keep in mind, but another important result we are making. Now what I am going to do is that I will take down this lambda G here. So what I will get, under root 1 minus lambda by lambda C square, lambda by lambda C whole square is equals to lambda G by lambda. Sorry. Lambda by lambda G. What I have done is that I have just taken this lambda G here and this I am taking here. That's it. This here and this here. Divided by lambda G. Now I can take square on both of the side. So if I take square on both of the side, what I am getting? It equals to lambda square divided by lambda G square. Right? Now what I can do is that I can divide lambda square on all of them. That means I can divide lambda square here, and lambda square here. So if I divide lambda square everywhere, what do I get? If I divide lambda square everywhere, so 1 by lambda square minus 1 by lambda C square divided by 1 by lambda G square. So what you are getting? 1 by lambda square is equals to 1 by lambda C square plus 1 by lambda G square. This expression also you need to remember. So wherever there is no subscript, that will come alone, rest all will come with addition. If there is subscript, those will come with addition, and if there is no subscript, that guy will come alone. So this is how I remember. 1 by lambda square is equals to 1 by lambda C square plus 1 by lambda G square. What is lambda? What is lambda C? What is lambda D? What is lambda G? What is this lambda? Lambda is the wavelength of uniform plane wave. What is your lambda C? Cutoff wavelength. Cutoff wavelength. And what is your lambda G? Guided wavelength. Is that clear to you? Fine. Okay. Guided phase velocity. What is your phase velocity? Phase velocity but guided. What is the formula? Omega by beta. But here what I am gonna write? I am gonna write guided phase velocity. So here I will write down guided phase constant. So here I am gonna write down beta G. So what is my beta G? Beta G is equals to beta under root 1 minus FC by F whole square. What is omega by beta? Omega by beta is equals to Vp only. And what is Vp? Vp is the phase velocity but of uniform plane wave. So what you are getting? Under root 1 minus fc by f whole square. So Vpg you are getting, that is Vp upon under root 1 minus fc by f whole square. So this was your phase velocity, right? There is another term which is group velocity. So till now we did not discuss about group velocity. Why is that so? What is group velocity? First see the formula. What is Vp? Vp is omega by beta, right? And what is group velocity? Group velocity is d omega by d beta. So what is the formula of guided group velocity if I am writing? So that is d omega divided by d beta g, right? Now previously what was our beta? Beta was omega under root mu epsilon. So when I was calculating Vp, what I was getting? Omega by beta. So what I was getting? 1 by under root mu epsilon. And when I was calculating Vg, although we did not calculate Vg previously, when we were studying uniform plane wave, we did not calculate Vg there. But if I had calculated Vg, then what I would have got? D omega by d beta. What is your beta? Beta is omega under root mu epsilon. If I do d beta by d omega, what I am getting? Under root mu epsilon only. And if I take the reciprocal, d omega by d beta, what that would be equals to? Vg, and what I am getting? 1 by under root mu epsilon only. So there your phase velocity and group velocity was same. But now what is the scene here? Here beta g is a function of omega. Here also beta was function of omega. But this was linearly dependent. So when you did the differentiation, Vp and Vg was same. Group velocity and and phase velocity were same. But now the scene is your beta g, and whenever you calculate group velocity, no, so first you will write down the definition, and then you will calculate d beta g divided by d omega, and later on you will do the reciprocal. So this is the method of finding group velocity. Okay, are you getting this point? What you need to do, first you will write down the definition that this I need to find out, then you will calculate d beta g divided by, or simply you will calculate d beta by d omega and then you will take the reciprocal. Let us say I have given some relation between beta and omega like this into 2, some expression I have given, and I am asking you now group velocity. What I am asking? Group velocity I am asking. So what you are going to calculate? First you are going to calculate d beta by d omega. So whatever the differentiation you do, whatever the answer you get, and then you take the reciprocal, d omega by d beta, and that would be equals to Vg. So this is the way of finding group velocity. Here also we are going to do the same thing. So first I am writing down the relation, beta g is equals to beta under root 1 minus fc by, or omega, let's write down omega, because fc can be replaced with omega. So omega c by omega whole square. So this is your beta g. Now the only dependence of beta g on omega is this only. Is that correct? What I am saying is that beta g is a function of omega in this term only. No, there is one hidden term. What is that? Beta is also having the function of omega. No? So beta g is equals to omega under root mu epsilon under root 1. Now I can solve this one. Can I write it down this one as omega square minus omega c square divided by omega square. And when under root is gone, when that under root is gone, then what I will be left with? Divided by omega only. When that under root is gone, I will be left with omega only. I hope what you understand what did I do here. Omega square minus omega c square divided by omega square. So under root omega square minus omega c square, under root omega square is omega only. So this is what I have done, right? Now this and this get cancelled. And if I do the differentiation now, what I am going to do? D beta g by d omega. So under root mu epsilon will remain there as it is. Then I do the differentiation. Omega minus omega square into 2 omega, right? Now this and this get cancelled. Now what is under root mu epsilon? Is it 1 by Vp? Is it 1 by Vp? Yes, it is. So let's take this derivation here. So d beta g divided by d omega, this is 1 by Vp. Under root mu epsilon is 1 by Vp into omega upon under root omega square minus omega c square. So what you are getting, d omega by d beta g is equals to Vp into under root omega square minus omega c square divided by omega. Now this omega goes into the under root, then how it will go? Under root omega square. This is how it will go. If this omega has to go in the under root, then this is how it will go, under root omega square. So this is how it will go. So if I need to take the complete under root, then this is how I will be taking it. Now what I am getting, what is d omega by d beta? I just took the reciprocal. So d omega by d beta is guided group velocity, that is equals to Vp into omega square divided by omega square, that is 1 minus omega c divided by omega whole square, or you can write down this thing, fc by f whole square. So this is your guided group velocity and this was your guided phase velocity. You let me know one thing here, which guy is larger, beta g or beta? Who is larger? Beta g is larger or beta is larger? What is this fc by f? This is some positive value, under root 1 minus some positive value. Let's just say it is something 0.2, and when I calculate the under root, let's just say it is coming some 0.6. When I calculate the under root of this, fc by f will be some positive value, so that I am assuming as 0.2. So when I calculate the under root, this is under root 0.8, let's just say under root 0.8 is 0.6. I don't know what is that value. So certainly this value will be somewhat less than 1, that's for sure. This value cannot be greater than 1. So this value will be less than 1. So what is the relation? Beta g is equals to beta into some value less than 1. I am calling that value as 0.6. Now if my beta was 10, then what would be my beta g? Beta g would be 6. So beta g is less than beta. So your guided phase constant is lesser. What about this lambda g? Lambda g would be greater than lambda because there is inverse proportion. Or you can see that this value will be, let's just say this value is some 0.5. If this value is some 0.5 and lambda is 10, so 10 by 0.5, what that would be? Lambda g will be 20. So in that manner also you can see. So lambda g is greater than lambda. And here, what about VPG? VPG will be greater than VP or less than VP? VPG will be greater than VP or less than VP? It will be greater than VP. Are you getting this point? Right? And what about this guy? VGG will be less than VP. So guided phase velocity is always lesser. Guided phase velocity is always lesser and not phase velocity, really sorry. Group velocity is always lesser than phase velocity. So phase velocity is always greater. What I mean to say is that your phase velocity will always be greater than group velocity. Another conclusion. Are you getting this point? And what is your VPG into guided group velocity? What is the multiplication of both of them? What is the multiplication of both of them? If you multiply this and this, then this and this will get cancelled. Basically, this under root 1 minus fc by f whole square, this expression will get cancelled, and what you are going to get? Vp square. And what is Vp there? Vp is the phase velocity, but phase velocity of a uniform plane wave. And for uniform plane wave, what is the scene? That your Vp is equals to Vg, right? For uniform plane wave, both are equal. We proved it, right? Vp equals to omega, then Vp was under root mu upon We have proved it, right? Just before this derivation, we proved this thing, that Vp was equals to Vg only for uniform plane wave. What we used to write, beta expression we wrote, then we did d beta by d omega, then this is what we are getting, and when you take the reciprocal, that would be your Vg, and that is equals to 1 by under root mu epsilon, and that's the same thing is there for Vp as well. So yeah, both are same, so that we have already proved. So number of conclusions we are making from here. So eventually you need to remember this formula and you need to remember this formula. Anyway, how you can remember that for the whole chapter what we were studying? For the whole chapter we were studying about phase velocity. So certainly phase velocity has to be greater than group velocity because we were studying it a lot. If something is greater, that's why we are studying it, no? So we were studying it a lot, so phase velocity has to be greater than group velocity. And if it is greater, that means this factor has to come downward because this is less than 1. So this factor has to come downward. So what will happen? Vpg would become greater. So this is how you can remember. The confusion would be that where this factor would come, downward or upward. So in group velocity, it is coming upward. In phase velocity, it is coming downward. Okay. So anyway, any trick you make and you will be able to remember this formula. Now we need to study about tilt angle. So very simple thing, you just need to remember the formula of tilt angle. What do I mean by tilt angle is that, so here what I have made this one. So this was our waveguide. This we have already seen. This was our waveguide. Now what I have made this one is that, so this portion I have made. So basically our wave can come something like this. Our wave can come something like this inside. Then it would be reflected back from the upper surface. So what I am making is that my wave is coming like this. Then it will be reflected back. Then again it will be reflected back in that manner. So what I am saying is that inside the waveguide, this is how my wave came. Then it will be reflected back and in that manner. So what is my direction of propagation? Here, what is my direction of propagation? If I show it here, my direction of propagation was AZ cap. This was my direction of propagation. And here, what is the direction of propagation? This is the Z direction I am making. Basically, this portion I am making. This portion I have made here. And I am saying that this is how my wave is entered. Then there will be reflections. Then again reflection. Then this manner. So what I call this as? This I call as incident angle. What this I call as? This I call as incident angle. And what this I call as? What is this angle? Between the wave and the direction of propagation. You can see that your wave is traveling in Z direction only. This is how it came. Then goes here, then goes here, then goes here, then goes ahead. So eventually your wave is propagating in positive Z direction only. So incident wave, the wave that is incident, and the angle between the direction of propagation. So this is the angle that is theta t. So which angle is theta t? You understood? So now this is my incident angle. On the conducting plate, this is the incident angle. So reflected angle will also be same. You know this thing. Now if I make a triangle here, so theta I plus theta t, what will be theta I plus theta t? That would be 90 degree, right? Can you show another theta t? If this is theta I, this would be 90 degree. What this would be? Theta t only. And what this would be? This would also be theta t. So you can say that incident wave and the direction of propagation. What is the angle? Incident wave and the direction of propagation. So another theta t will be this one. Incident wave and the direction of propagation. So this is your theta t. So sometimes in the examination they can mention theta t and they can ask you the questions. Now what is this theta t equals to? So what you need to remember, cos theta t is equals to under root 1 minus fc by f whole square. And that would be equals to sin theta I. Say yes or no? Because cos theta, in place of theta t, you can put a 90 minus theta I. So what that become? Sin theta I. So at least you need to remember this one, that this factor that was coming again and again. Under root 1 minus fc by f square. Under root 1 minus fc by f square, that is equivalent to cos theta t. And what is theta t here? What is theta t here? That is tilt angle. So that theta t is the tilt angle. Is that clear to you? Will you be able to keep this? Will you be able to keep this thing in your mind? So cos theta t is under root 1 minus fc by f whole square. So now you can write down all these formulas in terms of cos theta t as well. So let's write down the summary. But before that, let's see something. If your If your f is less than fc, let's just say your fc is 20 and f is 18. So what will happen? This value will be greater than 1. So 1 minus some value greater than 1. Let's just say your f was 10 only. So what will happen? 20 by 10 will be 2. So what you are getting? Minus under root 3. That is equals to cos theta t. Is that possible? No. So if f is less than fc, if f is less than fc, that means there is no propagation. Now if f is greater than fc, let's just say your fc was 10, but your f is greater, it is 20. So what you are getting? 1 minus 1 by 4. So what you are getting? Under root 3 by 2. So under root 3 by 2 is possible. That means theta t is equals to 60 degree. So from here, if the wave is coming here, that will make 60 degree angle. So that is possible. That means if f is greater than fc, then there would be propagation. Right? Now if wait a second, okay, I need to wait. Yeah, so we are back. So if f is equals to fc, then what will happen? What will be your cos theta t? That would be equals to under root 1 minus fc by fc whole square. So under root 1 minus 1, that would be equals to 0 only. So what is the value of theta t? 90 degree. Right? So what you are getting? Theta t is equals to 90 degree. That means if a wave is coming, that is coming directly like this, angle has to be 90 degree. So if wave is coming directly like this, then what will happen? It will be reflected back in this manner, or from here it will be reflected back. Then from here it will again be reflected back. Tilt angle will always be 90 degree. Again. So there is no propagation. At one point only, although I have made these separate, but at one point only there will be reflection, like incident reflection, incident reflection, incident reflection. So there is oscillations. So that's why we say there is oscillations here, because my tilt angle is coming out to be 90 degree. So at f equals to fc, this is how the wave will go. So here there will be reflections like this. Is that clear to you? Okay. So this was the concept of tilt angle. So in tilt angle, what you need to remember? Cos theta t. So this will work for everything, T, Tm. Till now, whatever the formula that we have studied, all the formulas are working for both TE and Tm mode. Because from where did we start? We started from this expression, and that was common for both TE and Tm. So all these formulas are working for both TE and Tm. So let's write down the summary. So common formula for both TE mode and Tm mode. So this thing we already know, kx square plus ky square is equals to gamma g square plus omega square mu epsilon, and this can be written as more as m pi by a whole square plus n pi by b whole square minus omega square mu epsilon is equals to gamma g square. So anytime you may require this expression. From here, if they are asking lambda g and all these expression, you can calculate. If they are asking cutoff frequency, then what is the formula? Vp by 2 under root m by a whole square plus n by b whole square. Certainly from here you can write down the value of lambda c as well, so that we don't need to remember. So here I am writing down all the formulas which you need to keep in mind. From fc you can write down lambda c as well. What about beta g? So for beta g, under root 1 minus fc by f whole square. And what was this expression equals to? 1 by lambda square is equals to 1 by lambda square is equals to 1 by lambda c square plus 1 by lambda g square. What is your VPG? For VPG, whatever that comes, that will come downward. 1 minus fc by f whole square. And what is your VGG? For for VGG, whatever that comes, that will come with VGG. And what was your tilt angle? Cos theta t, that was equals to 1 minus fc by f whole square. Now let's write down the formula, all these formula in terms of tilt angle. So can I write it down as beta cos theta t? Certainly I can write down as beta cos theta t. This, forget about it. here Vp by cos theta t, and here Vp into cos theta t, right? So these formula I can write down in terms of cos theta t as well. So they will only mention the tilt angle. From there you will find out the value of cos theta, then you go to know that this expression I have got, then I can apply these formulas. So these kind of questions can also come in your examination. Now we will write down the intrinsic impedance for both TE mode and TM mode. Now the expression will be different. So what is the definition of intrinsic impedance? Ex by Hy you can do, because if the wave is propagating in, if electric field is propagating in x direction, then where will be a magnetic field? Certainly in y direction. And if your electric field is in y direction, then where will be your magnetic field? In minus x direction. Say yes or no. Are you getting this point? Same goes for TM as well. If your electric field is, this is for TM. So Ex by Hy, if your electric field is in x direction, then magnetic field will be in y direction. Or if your electric field is in y direction, then your magnetic field will be in minus x direction. So minus sign I have put here. Now you need to put these expressions Ex by Hy. So for that I need to go back. Anyway I need to go back, or I can derive it as well if I have the capability. So let's derive it here only. So TE mode it is. TE mode, that means HZS is existing. What I need to write down? Ex. Ex and Hy are brothers, that I know. So let's write down first Ex expression. So minus gamma g upon h square, that term will not come. Directly I can write down the term, that will be minus j omega mu upon h square d by here x is there, so y hzs. And what about hy? For hy, what I need to do? Hx, then hy would come. So minus gamma g upon h square del by del y hzs. This would be your ex, this would be your hy. So this and this will be getting cancelled. H square and h square will be getting cancelled. Minus minus will be getting cancelled. So what I am left with? I am left with j omega mu upon gamma g. Very easily I derived it, right? Just I need to get the ratio. So this get cancelled, this get cancelled. So this is what I am left with. So you can write it down in a rough page. What is your gamma g? If the wave is propagating, then what is your gamma g? Gamma g. So gamma g is equals to, sorry, j omega mu it is. So if the wave is propagating, then gamma g is equals to beta g, j beta g. Because if wave is propagating, then it cannot be equals to alpha. It has to be equals to j beta g. So omega mu upon beta g. So neta t is equals to omega mu upon beta g. And what is your beta g? Beta g is equals to beta into 1 minus fc by f whole square. Now omega mu. What is your beta? Beta is omega under root mu epsilon under root 1 minus fc by f whole square. Then omega get cancelled. What you are left with? Under root mu by epsilon upon under root 1 minus fc by f whole square. So what is your neta t is coming out to be? Neta t is your neta upon under root 1 minus fc by f whole square. Because under root mu upon epsilon, what is that? Under root mu upon epsilon is your neta only. What is neta? Intrinsic impedance of uniform plane wave. This is your neta. So neta t is coming out to be neta upon under root neta upon under root 1 minus fc by f square. So this also you need to keep in mind. What about neta tm? So here I am going to do ex by hy. Ex by hy. But this is transfer magnetic mode. That means EZS is existing. So if I write down Ex expression, what that would be? Minus gamma upon h square. Sorry, minus gamma g upon h square d by dx EZS. And if I write down hy expression, So for Hy minus gamma g upon h square, then del by del y hz would come, then this would be negative, sorry, this would be negative minus j omega mu upon s square del by del x Ez would come. So this will be going towards 0 only, so forget about it. And when you take the when you take the ratios, this and this will get cancelled, h square will get cancelled, so you are left with gamma g upon j omega mu. So what you are left with, gamma g upon j omega mu. And what gamma g can be replaced with? Gamma g can be replaced with j beta g upon j omega mu. And what beta g can be replaced with? Omega under root mu epsilon, that is your beta, then under root 1 minus fc by f whole square divided by omega mu. Then here what you are getting is that omega get cancelled, so कुछ गड़बड़ हो गई क्या? नीटा नीचे कैसे आ रहा है? Let me check if there is some error. Yeah, so I did the error in the hy expression. Actually it would be epsilon, right? So it was a blunder. In hy expression, what you will be getting? J omega epsilon upon h square, right? And here there will be minus, and then del by del x ezs. This is what you would be getting. So epsilon would be there, no? So j omega epsilon. Okay. Then omega get cancelled. So what do you get? Here under root mu by epsilon into under root 1 minus fc by f whole square. So what is neta tm? Neta tm is equals to neta tm is equals to neta into 1 minus fc by f whole square. This is your neta tm. So if there is team, then you need to stand by the team. So this factor will come with neta, and then for the next one that will come downward. Here it will come downward. In the same manner that we remembered beta g. So what I said, beta, if you are beta, then you need to stand by. Certainly if you are in team, tm stands for team. So if you are in team, then certainly you need to stand by. So it is coming with neta. So this is the way I remember it. Team means it will come here. Okay. So this is the way you can remember. These two expressions are also new, which we have got. So two new expressions we have got. So these expressions were common for everyone. Now these are different for different cases. That for TE mode this is your neta, and for TM mode this is your neta. But all these expressions are common for both TE and TM. Are you getting this point? Okay, and this we can call as guided intrinsic impedance. So here I am not putting G. I can put G as well. But if I am putting TE, that means you understand that it is guided only. And here I am putting TM, so you understand that it is guided only. Okay. Now there is a term called dominant mode. What do you mean by dominant mode? In any kind of waveguide, whether it is rectangular waveguide or it is circular waveguide, in all kind of waveguide there would be some dominant mode. And what is the meaning of that? That this mode will have lowest cutoff frequency. What is the cutoff frequency formula? That Vp by 2 under root m by a whole square plus n by b whole square. Now this value, Fc value you need minimum. This Fc value you need minimum. Now what all modes we are having? TE and TM modes we are having. And what is the minimum of those? Like what is the minimum possible mode? Here minimum possible mode is TE10 or TE01. And here minimum possible mode was TM11. I hope you remember. This we wrote down. That TM0M cannot be there, TMN0 cannot be there, and TM00 cannot be there. And in this case, TE00 cannot be there. So 01 and 10, both two possible cases are there. And here the possible case is 11. Basically, what could be the minimum value of Mn? This is what I am asking. Because I need Fc to be minimum. If I need Fc to be minimum, that means I need minimum value of Mn, right? So here my m is 1 and n is 0. Now if I calculate fc for TE10, what do I get? Vp by 2, m is 1 and n is 0. So this will be gone, m by a, Vp by 2 under root m by a whole square, and m value is 1 only. So what I am getting, under root 1 by a whole square is 1 by a only. So Vp by 2a. What I am getting, Vp by 2a. So this is your cutoff frequency for TE10. Okay. Now if I calculate for TE01, that means m is 0 and n is 1. So what I will get, cutoff frequency for TE01. So here I will put 0, here I will put 1. So what I am getting, Vp by 2b. And for 1 1 if I calculate, what do I get? Fc for TM11. That would be Vp by 2 under root m by a whole square, 1 by a whole square plus 1 by b whole square. Now you yourself let me know which of them is minimum. And if you remember, we have one condition. What is that? That our a is greater than b, right? When I make the waveguide, we always take this condition that in x direction we have a which is greater than b. So which of them will be having the minimum cutoff frequency? Certainly this is out of the race. This is having the maximum, because here it is having a and b both component. They are at least having b only. This guy is at least having a only. Let's just say if a is equals to 1, not 1, if a is equals to 2 and b is equals to 1, then calculate these values. If you put a equals to 2 here and b equals to 1 here, then calculate this value, then calculate this value, and then calculate this value. Which one will be minimum? This one will be minimum, right? The cutoff frequency of TE10 mode is minimum. This is minimum. Why is that so? Because directly I can see there that this is out of the race, because a and b both are there out of the race. Here a and b are there. Now this is Vp by 2a, this is Vp by 2b. Vp is same for both of them. A is greater than b, that means this value is lesser. If a is greater, that means this value is lesser. So what is the minimum one? This is the minimum one. So what is your dominant mode? So my dominant mode is TE10 mode. So for rectangular waveguide, this statement I am gonna write down. For rectangular waveguide, dominant mode is, what is your dominant mode? TE10. TE10. Okay, this is your dominant mode, which should be in your mind. And what is the cutoff frequency for TE10? So you do not need to think about it. That's our Vp by 2. Then I will put m and n value. Simply you need to remember Vp by 2a. So this is your cutoff frequency for TE10 mode. And what will be your cutoff wavelength? That would be lambda is equals to Vp by Fc. So if they put the value, what they are getting? 2a. So what is the answer? 2a. So this should also be in your mind, that if they are asking me the cutoff wavelength for dominant mode, then I just need to take that twice of the bigger size. That's it, twice of the bigger side. So this is your cutoff wavelength of dominant mode. Now two more things are remaining, that is the power calculation and the field pattern. After that we need to solve problems. So those two things we are going to see now. What are the two things? Power calculation and field patterns. So I will have to change the slides because these are too much slides. So I will change the slide and then we will start studying about power calculation and about field patterns. Okay, so I will take a pause. You can also take a pause now. Okay, yeah. So let's start studying about power transfer in rectangular waveguide, or you can say power calculations. So from this particular topic, questions are very rarely asked. The last question was asked in GATE 1994. So only till now, till this date, only one question has been asked on this particular topic, but still we need to do. And that last was asked in 1994. Okay, yeah. So we need to find the power in rectangular waveguides. We already know what is our time average pointing vector, that is 1 by 2 real of ES cross HX conjugate. When we do this calculation, what is the final answer we get? So when it was our uniform plane wave, the answer was E naught square upon 2 neta. So here also the answer would be 1 by 2 neta EXS square plus EYS square, magnitude of EX square plus EY square. That is your time average pointing vector, and certainly the wave propagation is in Z direction, so AZ cap. Are you getting this point? And what was the other formula? 1 by 2 neta H naught square. This was the other formula, because E naught square divided by 2 neta, so E is equals to neta H, so neta square H naught square divided by 2 neta, and this was getting answered, so 1 by 2 neta H naught square. So here also the same thing, 1 by 2 neta Hx square, because here there are two components, no, x and y, so those both components we are writing, plus Hys square Az cap. Is that clear for you? Okay. And if someone asks you total power flow, so what we used to do, P average dot ds and then integration. Same thing we are going to do here. P average is 1 by 2 neta. I am writing this formula, okay. You can write down this formula as well, but majorly we write down the formula in electric field. So 1 by 2 neta Exs square plus Eys square dx into dy, where the limit of x is from 0 to a, because what is our rectangular box? X goes from 0 to a and y goes from 0 to b, and y goes from 0 to b. So you would be having the expression of Ex, you would be having the expression of Ey. You can find out their magnitude, do the take the square, do the summation divided by 1 by 2 eta. Now now discuss this eta, that I forgot to tell. What about this eta? This eta could be this eta and this eta. Depending on the modes, these eta could be eta TE or eta TM, right? Depending on the mode, it could be eta TE or eta TM. So this thing you will take care. Okay, here I have written eta, but if it is TE mode, you will write down eta TE, and if it is TM mode, you will write down eta TM. Okay, let me make these lines better. How we can show it? Okay, it is fine. Yeah, this is how we can show it. Fine. Now there is very rare chance that they will ask you questions from here, because EXS, that particular expression is very complex, right? Like there will be j omega upon h square, then m pi by a, these many things will come. Basically EXX is a function of cos x sin y, but before cos x and sin y, here also some things would come, no? Before cos x and sin y, here also some amplitude would be coming, and that is known as mode of EXS. Mode of EXS. So cos x sin y would certainly be there, cos m pi by a into x and sin n pi by b into y, but this expression will be your EX, and that would be very complex, and this expression will be your EY, and summation of both of them you need to do. So the answer would be very complex. So mostly they would ask power flow in dominant mode only. So we will study about power flow in dominant mode, or you can say power transfer in dominant mode. So now we will pick that dominant mode. So in dominant mode, what happens? What is your EXS? EXS is a function of cos x sin y, right? Cos x sin y. Now if I talk about this is a function of cos x sin y, then I can write down the function, like there will be some magnitude which I don't care, cos m pi by a into x and sin n pi by b into y. If you put 1 0, in place of m you put 1, in place of n you put 0. Sin 0 is what? 0. So anything is there, I don't care. Cos pi by a into x will be there, but n is equals to 0. In dominant mode, n is equals to 0. So sin 0 will be 0 only. So this complete expression will go to 0. So EXS is 0. Same goes for HY as well. In dominant mode, if EX is 0, then certainly HY is also 0. Right? And these two are non-zeros. This is also non-zero and this is also non-zero. EY and HX are non-zero. Are you getting this point? What did I do here is that I am finding our EX, HY, EY, HX expression for dominant mode. Why I am finding? Because I need to find the power flow. So for power flow, you would require EX, EY, HX and HY expressions. Then I got to know that EX and HY are 0 for dominant mode and these are non-zero. Okay. Now P average I need to write. So for P average, what will be the formula now? 1 by 2 eta mode of EYS square only, right? And since it is TE mode, so neta TE. Or you could have written 1 by 2 neta TM, and since it is YTM, sorry, it is TE mode only, no? So 1 by 2 neta TE and only HXX expression is there, so this HX square, because this term is gone. Which term is gone? Here HY is gone and here EX is gone, right? So no need to mug up the expression. Just by looking at this cos x sin y, we can tell the answer that at TE10 mode, these will be 0 if this is a function of this thing. Okay, right? Now I need to calculate the power. So here when you calculate EYS, something complex expression would be coming on this side. What I know is that EYS will be my function of sin x cos y. So I am pretty sure that sin m pi by a into x and cos n pi by b into y would be coming. But here there will be some amplitude, like it would be anything, gamma g upon s square, whatever the amplitude we will be getting. Here there will be some amplitude, and that amplitude I am calling as E naught. Are you getting this point? This E naught has nothing to do with the EZS amplitude. Okay, EZS amplitude is some E naught dash. Now from EZS, EYS is derived. So this will have some new amplitude, and that amplitude I am calling as E naught. Are you getting this point? So this E naught has nothing to do with EZS. You can write down somewhere else on this page that don't get confused, that this E naught and this E naught are different. Here whatever the amplitude that I am getting, that I am calling as E naught. Okay, well and good. And here EZS is also 0, no? Here EZS is also 0 because it is transfer is electric mode. So EZS is also 0. So in the examination, what happens is that they will tell you that total electric field component, like basically here EZS is 0, EXS is 0. So only EYS is there. In TE10 mode, EZS is 0, EXS is 0, EYS is only non-zero. So if I find out total electric field, so what I write? EXS, AX cap plus EYS, AY cap plus EZS, AZ cap. But what is left here? Only EYS is left. So what happens in the examination is that in the question they give you that maximum amplitude of electric field present in dominant mode. So you would know that in dominant mode only EYS is present. So the amplitude that is given is this one. Are you getting this point? So that's why I am writing down as E naught. Now I will derive the formula. That formula will be important. Now what I need to do? I need to find the, first I will find out the P average. So P average would be simply 1 by 2 neta TE and mode of EY square. What is mode of EY? That is E naught square. That's it. Okay. And let's just say HXS was our H naught sin m pi by a into x cos n pi by b into y. But in case of magnetic field in TE10 mode, HZS will be non-zero, no? So they will never say that maximum amplitude of magnetic field. In the question, they will never say that maximum amplitude of magnetic field because they know that HZS is also existing and HXS is also existing. What they can give is that in x direction, the maximum amplitude of magnetic field is this. Are you getting this point? So they need to denote the direction as well. If they are talking about magnetic field, then they need to denote the direction as well. They can never say that maximum amplitude of magnetic field. That will be senseless. So here two magnetic field component are present and only one electric field component is present. So that was the important thing. So we can derive now, we can derive with respect to here electric field we are deriving. Then simply we will put neta h and we can derive for magnetic field as well. So 1 by 2 neta T E naught square. So this is our P average. Now if I find the total power, so for total power, what did I tell you? We need to do the integration 1 by 2 neta Te. Really sorry, here what did I do? Here mode of EYS we are writing, no? So one error I did here. Mode of EYS we are writing. First thing is that here e to the power minus gamma gz will also come. Here e to the power minus gamma gz will also come because wave is propagating in plus z direction. Also, if you talk about the magnitude, then this magnitude will be there, no? This is the magnitude only. Here there is no time term. This shows propagation. If you talk about the magnitude, then this will be the magnitude, no? So here I am writing magnitude as E naught. That is wrong. Magnitude is complete. Sinusoid, cosinusoid, this complete is magnitude. In the here also in this analysis I told you that my magnitude will be that complex expression only. No, sinusoid and cosinusoid will also come. No, you are talking about the magnitude. You are not talking about the maximum value. You are talking about the magnitude. So magnitude will be E naught square sin square m pi by ax, sin square m pi by ax and cos square n pi by by, because we are talking about the amplitude. So that was an error from my side. Here also what will be the amplitude? H naught square sin square m pi by ax cos square n pi by b into y. So this is the amplitude, right? Now I need to find P total. Just a second. Okay. 1 by 2 neta T E naught square then sin x cos y, sin x cos y cos square n pi by b into y and dx dy. Okay, and here x is going from 0 to a and y is going from 0 to b. Value of n is 0. For TE10 mode, value of n is 0, no? For TE10 mode, m is equals to 1 and n is equals to 0. So n equals to 0 you will you will put here. So cos 0 is 1. So this term is gone. For TE10 mode, simply this will not even exist for TE10 mode because n is equals to 0. Here also n is equals to 0. So this will not exist. So this will also not exist. This will also not exist because n equals to 0. So cos 0 is 1 and m equals to 1. So m equals to 1 you will put here. Here why I am doing the derivation? Here I did not do the derivation because that was not important. This derivation can help you anywhere. So that's why I am doing the derivation. Now what I need to do? 1 by 2 eta T E naught square, that is constant. So E naught square divided by 2 eta Te. Then this is the differentiation with respect to x and the limit of x is from 0 to a, sin square pi by a into x dx, and from 0 to b this is dy. If I solve this one, I think you should be able to tell what will be the answer of this one. That would be 1 by 2. What is the answer of this integration? That would be 1 by 2. Sin square term is there. Or let's solve it. X equals to 0 to a. What I can do? I can apply cosinusoid functions. 1 minus cos 2 pi by a x divided by 2. This I need to do, and when here I do the differentiation, when here I do the integration, what I will get? B only, because integration is y, so here I will be getting b. So what I am getting? E naught square divided by 2 neta Te. Here you are getting b only, and if you do the differentiation here, sorry, integration here, why I am saying differentiation? If you do the integration here, what you are getting? X by 2. What will be the integration of this one? Cos. That would be sine. right? Sine 2 pi by a x divided by 2 and divided by 2 pi by a. I am doing the integration of this quantity. Simple integration. I hope you should know it. I hope you already know it. So when you put the limit, so if you see this expression, first you will put the limit as a, x equals to a, then what it will be? Sine 2 pi. Sine 2 pi is 0. Then you will put the limit at as x equals to 0. What will be sine 0? 0 only. So this term will be going towards 0 only. So here what you are going to get? A by 2. So what is the final answer you are getting? So this is how you are going to remember. Sir, E naught square divided by 2 eta TE into only B. Why only B? Directly B will come. Why only B? B by 2 will not come. B by 2 would have come if this component was present. But this component is not present. The sinusoid component is not present. Here sinusoid component is present. That's why A by 2 is coming. Because what will happen is that this will be squared, and if it is square and when I do the integration, it will be A by 2. But here this component is not even there. This component has become 1. If this component has become 1, then simple integration of dy is 1 only. So that's why directly B is coming. And what about A? So this is how you will remember the formula. So this should be your way of remembering the formula in mind. Otherwise the final formula is E naught square divided by 4 eta TE AB. But it would be tough to remember. Certainly it is tougher to remember, but this is very easy because this formula we already remember. E naught square divided by 2 eta into A into B by 2. Okay, E naught square by 2 eta into B into A by 2. Not sorry, it should not be A into B by 2. Although answer would be same, but how we will be remembering? E naught square by 2 eta TE into B into A by 2. Because for B there is nothing, and for A there is sinusoid component is present. That's why it would be A by 2. Are you getting this point? So this is the answer. And if question is coming from power flow, then certainly it will come on this formula only. I am pretty sure, 100% I am sure. Okay, if the question is coming, then it will come on this particular formula only. And if you need to write down this formula for magnetic field, then what you will write down? 1 by 2 neta TE H naught square. This expression is replaced with 1 by 2 neta TE H naught square A by 2 into B. That's it. And what is your H naught? H naught is associated with mode of HXS. Only mode of HXS. Are you getting this point? The magnitude of the maximum magnitude of magnetic field in X direction. Here they can write down the magnitude of electric field. They do not need to show the direction, because here Z and X all component are 0, only Y is present. So by default you need to think that this is the this is the amplitude in Y direction only. But here they need to mention that H naught is the I am really sorry for this interruption. Okay, let me pause. Yeah, so what I was saying, here they need to tell that H naught is the amplitude in X direction, right? And they will call this as maximum amplitude, because for maximum this sinusoid component will be 1. So maximum amplitude, that means H naught is the component of a magnetic field in X direction. So these are the formulas we have developed. Let's solve the question which was asked in GATE 1994. A rectangular hollow metallic waveguide of internal cross section is given. So A is always the bigger one. A is always the bigger one. So here I can see that my A value is this, and my B value is 3.556 centimeter, and my frequency is 3 gigahertz. In T10 mode it is calculate the maximum power handling capability of waveguide assuming maximum E field to be 30 kilovolt per centimeter. So power handling, total power handling we need to find. So what will be the formula? That sir, this we already remember, E naught square divided by 2 eta T into A by 2 actually into B. That's it. This is the formula, sir. So now sir, I need eta TE. What is my task? This is the formula, but my task is to find eta TE now. Eta TE. For eta TM, what do you get? For eta TM, you need to stand by the team, but here you need to you do not need to stand by TM since it is TE. So the formula is neta upon under root 1 minus FC by F whole square. Okay, so here you would require the value of FC as well. So what would be your FC? FC for TE10. Do you remember the formula directly? Yes, Vp by 2A. Here they did not mention anything, any medium they did not mention. So I will assume air. I will have to assume air. I cannot do anything because they did not mention any medium. So Vp will be 3 into 10 to the power 8 to 7.366 into 10 to the power minus 2. So I will do the calculation. 3 by 2 divided by 7.366. So you are getting 2.36 gigahertz. This is the value of FC you are getting. So which factor will be required? Under root 1 minus FC by F whole square. This factor will be required. No? This factor will be required. So let's find out the value of this factor because that will be required here. So directly I am finding out the value of this factor. Okay. So what that would be divided by what is the value of F? F is 3. Basically this will be 1 by 2 under root minus 2.036 divided by 3 whole square. And then this value I will be getting. So divided by 3 whole square, then minus 1 and then under root. So 0.734. And then if I need to calculate neta TE, so that would be 377 divided by 0.734, right? Because this is 377 only. Neta air is 377 divided by 0.734. So reciprocal into 120 into pi. So you are getting 513.38. This is your neta, that is ohm. E naught value is given, all other values are given. So now I need to find P total. So what is my E naught square? That is 30 into 30 into 10 to the power 6. Because E naught square I need to do. And divided by centimeter is there. Divided by centimeter is there. So that means A and B value also I will put in centimeter only. Here divided by centimeter square will be there. No? So A and B will also be in centimeter. So the unit you need to take care. Here kilo I converted into 10 to the power 3 into 10 to the power 3. So that is 10 to the power 6. And this is 513.38 into 7.366 into 3.556. Okay, yeah, so this calculation we need to do. So reciprocal into 900 into 7.366 into 3.556. Let me see the calculation once. Yeah, one issue was there. Here I forgot to apply 2. E naught square by 2 eta is there. No? So don't do this calculation. Don't do this calculation error. And another divided by 2 will also be there. E naught square divided by 2 eta TE divided by 2 eta TE. Then A by 2 into B. So formula I applied very wrong. That was a big error from my side. This was your E naught square divided by 2 eta E into A by 2 into B. So that was a big blunder from my side. And the answer is coming out to be 11.48 megawatt. So here this answer is written wrong. This answer is wrong actually. Forget about this answer. This is the actual answer. Actually, double was written, I guess. Yeah, I had written double answer, but that is wrong. This is the correct answer. So just you need to keep the formula in mind: E naught square by 2 eta T into A by 2 into B. E naught value is mentioned, and eta T value you find out. Then 900 divided by 2 into A by 2 into B. So let me do the calculation once again. So 900 divided by 2. Yeah, I will get the same answer only. Now you can solve this question, but here maximum permissible magnetic field in x direction inside the waveguide is given is this. Same question is there. D2 same question is there. You need to find the, again you need to find the power. So you can solve it on your own. What will be your eta TE here? Eta TE will be same as it is. What that would be? 513.38. 513.38 ohm. And if you need to find the P total, that would be 1 by 2 eta TE into H naught square. 1 by 2 eta TE into H naught square into, again wrong formula. Here eta will come upward. 1 by 2 eta TE H naught square into A by 2 into B. So 1 by 2, what is eta TE? Eta TE is 513.38 into H naught. The value of H naught is 11.37 whole square into A. So here it is given in meter. So this also I will write down in meter only. So 7.366 into 3.556. So this will be centimeter into centimeter square. So here I need to put 10 to the power minus 4. So this calculation I need to do now. So 11 divided by 2 is also there. Again this is a big blunder. I'm again forgetting these two. So do not forget these two. Okay, 1 by 2 eta TE into H naught square into A by 2 into B. And certainly if they are asking question on power calculation, they will ask on your dominant mode only. Okay. Yeah, so let's do this calculation. 513.38 into 11.37 into 11.37 into 7.366 into 3.556 divided by 4, and then 1, 2, 3, 4. Let me do it again. Let me do the calculation again. Yeah, so this is the answer we get. This is the total power. So that's it. That's it about the power calculation. Now we need to see one more topic, that is field pattern. Field visualization we will do, that how the field will look like, and then we need to see the field patterns for different modes. First we will do the visualization for TE10, then I will tell you that method that how to visualize the field for other modes. But that we can see in the next lecture, because I am not feeling good now. You can see I am coughing again and again. So I wanted to do that this thing in this lecture only, but let's do it in the next lecture. In the next lecture we will do this calculation. Also we will solve an assignment. A lot of questions we are going to solve. So this calculation we can do, and questions we can solve. So in this lecture we have studied the parameters. Along with that we have studied this power calculation. For power calculation we have seen the numerical as well. But when we studied about those parameters like neta TE, neta TM, beta G, lambda G, FC, these values we find out. So for them we did not do any numericals. So for those particular concepts we are going, for those particular formula we are going to do the numericals in the next lecture. Also we are going to see this field pattern topic. Fine. Okay. Thank you very much.